Hey everyone, thank you so much for joining in and welcome to Edureka webinars. So folks, as we progress in today's session, we are going to learn and discuss about the smart contracts in blockchain. So that's the agenda of today's session. Okay, so let's get started and let's look into the today's agenda. See, as we progress in today's session, we will understand about Ethereum, Ethereum accounts, smart contracts, and we'll also look into the Ethereum virtual machine, deploying the smart contracts, dApps and DAO. So these are the various topics that we'll be discussing today. So let's get started, folks. So let's understand why Ethereum. So Ethereum, when we talk about it, okay, before we talk about why, okay, so let me just tell you what exactly is this. See, I can say that the this Ethereum is one of the there's a lot of innovations that is currently going on in this blockchain technology that have actually resulted in the development of this new platform called Ethereum. So just like Bitcoin, Ethereum is also a distributed network, and it is rightly termed as blockchain 2.0. And this has actually paved a path for developers to contribute to the blockchain community. So let's start by understanding what exactly is this Ethereum. See, the reason that you want to learn about this Ethereum because this is one of the major or second major innovation in the blockchain since the invention of my Bitcoin. So here, the Bitcoin can be described as a digital money, but here, when we say Ethereum, Ethereum is a decentralized platform for programming a digital money. Now, when you look closely, both Bitcoin and Ethereum are actually powered by distributed ledger, but both of them would differ in many technical ways. When we talk about Bitcoin, so the concept is digital money. And when we talk about Ethereum, it's like the world computer. The founder is Satoshi Nakamoto, who is a mysterious guy from the Bitcoin invention. And the Ethereum is Vitalik Buterin and the team. So they are the founders of this Ethereum. And for the Bitcoin, the scripting language that is being used is Turing incomplete. And in the Ethereum, it is Turing complete. Okay, now when we talk about Bitcoin and Ethereum, they're often compared to each other. But remember that two were designed with two different or like very different vision and the goals. So Bitcoin is an established cryptocurrency used for trading, and Ethereum is a multi-purpose platform with its digital currency as the fuel for smart contracts functionality. So that's the reason that you need to be aware of this Ethereum. Now that you have understood as why Ethereum, let's understand what exactly is this Ethereum. So Ethereum is an open source public blockchain based, like I would say, it is a public blockchain based distributed computing platform for building the decentralized application. So before the creation of Ethereum, the blockchain applications were designed to do a very limited set of operation. The Bitcoin and other cryptocurrencies, for example, were developed exclusively to operate as a peer-to-peer digital currencies. Now, at that time, the founder, Vitalik Buterin, he envisioned Ethereum as a platform for developers to write the programs on the blockchain. Now, in order to accomplish his goal, he used the similar blockchain designs and the protocol as that of Bitcoins. And along with that, he improvised it to support the applications beyond the currency issuance. So anyone across the globe can connect with the Ethereum blockchain to develop a program and can maintain the current state of the network. Hence, the term that is currently used as world computer. Okay, so that's the core idea about this word computer. Now, we have already mentioned, like the question is, what was the need of Ethereum when the Bitcoin already existed? As I mentioned earlier, yeah, this actually compares the Ethereum and the blockchain. So Bitcoin is for digital money, Ethereum is for word computer. cryptocurrency token is BTC. This is Ether. Turing incomplete. This is Turing complete. The consensus algorithm is SHA-256 here. This is ETH-hash. Then the coin release method is early mining. This is through ICO. So average block time is closer to 10 minutes. Here, the average block time is 12 to 15 seconds. Okay, this is the overall idea about the comparison between Ethereum and the Bitcoin. Now let's understand the types of the Ethereum accounts. So the Ethereum network has two types of accounts. Okay, they are external account and the contract account. Now these accounts, both external and the contract, are referred to as state objects and compare the state of the Ethereum network. Here, every state object has a well-defined state. So for external accounts, the state comprises of the actual, I would say, account balance. And when we talk about the contract account, the state is currently defined by the memory storage and the balance. Okay, so these are the two common types of accounts. And here we can say that external accounts as simply as an account, because these accounts are owned by and they are actually represented by the external agents of the network, which include every ordinary user, miners, or it could be the automated agents. Now, these external accounts are generally controlled with the help of public key cryptography algorithms like RSA. And the main purpose of the external account is to serve as a medium for the users to interact with the Ethereum blockchain. On the other hand, when we talk about the contract accounts, so here contract accounts are the collection of code which resides on the blockchain at a specific address. And these contracts are invoked by the external account. Or it can also be invoked by other contracts through a specific call to action function. And these contracts are written in high-level scripting languages like Solidity, Serpent, or LLL. And every contract that resides on an Ethereum blockchain is stored in a specific format called EVM, which is nothing but Ethereum Virtual Machine Bytecode, which is an Ethereum specific binary format. Okay, that's the overall idea and the difference between externally owned accounts and the contract accounts. Now here, when we talk about this Ethereum virtual machine, so as I mentioned before we move to these smart contracts, let me just give you a background about this Ethereum virtual machine. See, Ethereum, I would say in a rustic way, it defines the set of generalized protocols which have become the pillars of the development of decentralized application. At the heart of this lies the Ethereum virtual machine. Now, if I want to describe the architecture, this is how the architecture of the Ethereum virtual machine would look like. So here, this Ethereum virtual machine, as you can clearly see from the diagram, is not only completely sandboxed, but it is also completely isolated. See, this Ethereum virtual machine is completely isolated. That means the code that is currently running on the EVM has no access to the network or the file system and can sparingly access any other contracts. Okay, so that's the core idea that you need to remember when we talk about this Ethereum virtual machine. Now, coming back to our learning journey. So let's talk about the contracts. Okay, that is the smart contracts. So let's look into the smart contract. See, a contract that self-executes and handle the enforcement, the management, performance, and the payment, that's actually called as a smart contract. So I can say that it can be defined as a contract that self-executes and handles the enforcement, management, performance, and payment, which is a computerized protocol wherein you write a standard contract rule, which is immutable one. Okay, that's what we call it as a smart contract. To give you an example, if England wins the match, send 10 Ethereum, okay, to Bob, and else send 10 Ethereum to Andy. Okay, so this is an example, which is a smart contract. Okay, so here, when we talk about the Ethereum, so we also need to talk about the Ethereum cryptocurrency. So this Ethereum runs on its native token, which serves two main purposes. One, Ether payment is required for the applications to perform any operation so that broken and the malicious programs are kept under control. And Ether is rewarded as an incentive to the miners who contribute to the Ethereum network with their resources, much like the Bitcoin structure. So every time a contract is executed, Ethereum consumes token, which is termed as gas, to run the computation. Okay, that's the overall idea that you need to remember. Now, here we have mentioned that. So like here, the question is, what was the need to develop a smart contract specific language? Why couldn't we use the already existing language? So that's one of the questions that you might have when we talk about this smart contracts. Well, the reason that we will be using, because here this Solidity is what we use it for the smart contracts. So when we talk about this Solidity, okay, so it's a contract oriented high level language for implementing the smart contracts on the Ethereum virtual machine. Okay, that's the core idea of this Ethereum Solidity. So here, when we talk about this Solidity, so I can say that this is a tool which we use it to generate the machine level code to execute the EVM. Okay, the Solidity compiler takes the high level code and it actually breaks down into the simpler instruction. And this Solidity code is encapsulated in the contracts. Okay, that is something that you need to remember. Now, the next topic that we have got is Ethereum virtual machine. So here, as I mentioned earlier, when we talk about this Ethereum virtual machine, so Ethereum virtual machine is nothing but the contracts written in smart contract specific coding, specific programming language are compiled into bytecode, which an EVM can read and execute. Okay, that's what we call it as an EVM. So the question is, so if the EVM is running the application code, what's preventing a piece of code from running forever or overloading the network? So that's where the Ethereum gas comes into picture, as I was speaking earlier. Okay, so here when we talk about gas is the unit, or is the unit for the amount of computational work which has been done by a computer for one cycle of contract, and gas limit is the computational work done by the gas limit. So it's the computational work done by the gas, okay, which will limit where we can actually limit the maximum amount of gas the contract can use for its execution. Okay, that's the relationship between gas and gas limit. So here gas is required to be paid for every operation which is performed on the Ethereum blockchain. Now its price is generally expressed in Ether and it's decided by the miners, which can refuse to process the transaction with less than a certain gas price. Okay, and in the previously I have mentioned about the Ethereum virtual machine, right? So Ethereum virtual machine is the engine in which the transaction and everything gets executed. So the EVM enables the development of the potentially thousands of different applications all on one platform, and the contracts written in a smart contract specific programming language are compiled into bytecode, which an EVM can read and execute. So I would say that it actually handles the internal state and the computation in the Ethereum. So for the practical reason, you can think of this EVM as the large decentralized computer with millions of objects called accounts, which have the ability to maintain an internal database, execute the code, and also they can talk to each other. So with EVM at its heart, I can say this Ethereum enables the development of potentially thousands of unstoppable applications. Okay, now moving on. let's talk about the deploying the smart contracts. Okay, so coming back over here. So when we talk about the deploying, so we've got the Ethereum platform, and then we'll have the smart contracts and dApps and DAO. So that's the Ethereum as a platform. So when we talk about the decentralized application, that is dApps, so when we talk about this dApps, that is decentralized application, some of the key things that you need to know about is it's an open sourced, decentralized, and it will have a consensus mechanism, and it will be running with the help of tokens. Okay. Now, when we talk about the decentralized autonomous organization, so these are actually the organization. Okay, these are actually the organization that exist entirely on a blockchain and are governed by its protocols. Here, the decentralized autonomous organizations comprise of a global network of nodes and the members that all work together and create a unison to manage their distribution. Okay, that's the core idea of this decentralized anonymous organization. Now here, proceeding further, let's have a look into the future of Ethereum. Okay, let's look into the future of Ethereum on the, I would say, the future of the application, that is Ethereum dApps. See, when compared to the traditional application, so I can say this Ethereum dApps, they actually provide a lot of advantages. So these would include the improved stability, no downtime, higher reliability, and no need to integrate third-party payment gateways. The user can transact directly using Ether. Signing up or creating an account is not actually required, and users are automatically assigned the credentials. Okay, and along with that, we also have the proven privacy and the security. So these are advantages that we would see right now. Now, all these advantages are, I would say, it's probably enough for most developers to start adopting the blockchain approach for the application deployment. In fact, many tech giants like IBM and Facebook, they have started working on the projects over the blockchain. And we might even see the blockchain renditions of popular mobile and the computer apps in the very near future as well. All right. So team, with this, we come to the end of today's session, which is about introduction to blockchain and the smart contracts. So I hope this gave you an overall idea about how amazing this technology is and how amazing this blockchain platform is. Okay, folks. So thanks again for joining in. So thank you so much, guys. Take care.